right, we have a graph of the original function just to give us an idea of where we're headed. I've created a little table here to illustrate some of the points. For example, -4 and 4 are not in the domain of the original function, which is from -3 to 3 inclusive. By the way, this should have been a comma here, not a dot. At the endpoints of the interval, the value of the function is 0, because if we put 3 or -3 in here, the number into the radical will be 0, the square root of 0 is 0. And likewise, if I put 0 in for x, I get a 0. Now, it looks like these points right here where x is -2 or 2 might be close to producing relative maximums and minimums, but we need calculus to figure out exactly where those are located. To do that, we're going to find the first derivative, which in this case requires us to use the product rule. Rewrite the square root of 9 minus x squared as 9 minus x squared to the 1/2 power. So the product rule says I'm going to take the first function, which is this x, times the derivative of the second. So I'll bring, I'm taking the derivative of this function right here. So I'll bring the 1/2 down front, reduce the exponent by 1, becomes -1/2. Then the chain rule indicates it will multiply by the derivative of the inside, which is the derivative of -x squared is -2x. And then continuing with the product rule, it's plus the second function times the derivative of the first. And that's what this 1 is. The derivative of x is 1. And then cleaning that up a little bit, I can see that these 2's cancel out. And in the numerator, I'll have x times -x is -x squared. And I can move this to the denominator, and I'll rewrite it using a square root symbol. And then plus this term, which is just the square root of 9 minus x squared. And we want to know what are the critical numbers. That's when the first derivative equals 0 or when it's undefined. And this first derivative is undefined when x equals 3 or -3, because we would be dividing by 0 right here. So -3 and 3 are critical numbers. And when does it equal 0? Well, if I multiply every term by the square root of 9 minus x squared, picture like I'm going to multiply by 9 minus x squared. These would cancel out, and I get this minus x squared. When I take the square root of 9 minus x squared times itself, I get what's under the radical sign. And then combining similar terms, getting the x squared by itself, we get x equals the square root of plus or minus the square root of 9 over the square root of 2. But the square root of 9 is 3. Rationalizing the denominator, I get plus or minus 3 radical 2 over 2. Okay, so that's the x coordinate of the lowest points here. And if we go to board 2, you'll see what I'm talking about right here. 3 radical 2 over 2 is about 2.12. And if I plot and I let a equal that value, f of a is this point right here. So there are the coordinates of a relative maximum, and there are the coordinates of a relative minimum. Opposite of a, comma, f of a. Over here, this is actually the first derivative test. So we put all the critical numbers on a number line. I have little x's here for the -3 and 3 to show that they're not really in the domain of the derivative. But that, and then I put -3 radical 2 over 2 and 3 radical 2 over 2 on this little number line. That divides this number line segment into 3 intervals, and we want to pick test numbers in each interval to find out what the sign of the first derivative is in that interval. So I'm going to go to black here. I take negative 2.5, which is between negative 3 and negative 2.12, and plug it into this derivative. I can see that the radicals are going to give us positive numbers. And when I square negative 2.5, I'm going to get a positive, but then I take the opposite of that. So if I put negative 2.5 into this function, the question is, will this negative term be less than or greater than this term? And I'll let you do that, but you'll find out that this is negative. The first derivative is negative in that first interval, which tells you the original function is decreasing. That means the slopes of the tangent lines are negative in the interval from negative 3 to negative 3 radical 2 over 2. The function is decreasing. And likewise, if I put a 0 in the first derivative, I'll get 0 for this first term, and I'll get a positive number for this second term, which tells you that the original function is increasing. The tangent lines have a positive slope. They're going uphill. And finishing it up over here, we will see that if I put negative 2.12 into the first derivative, you'll find out that the sign is negative, so the original function is decreasing. That gives us the relative minimum here, because I went from decreasing to increasing, and a relative maximum here because I went from increasing to decreasing. For absolute max and mins, we also have to test the endpoints. We've already done that here. These are not greater than 4.5 or less than negative 4.5. So these values right here are also the absolute max and absolute min of this function on the interval from negative 3 to 3. There you go. Hope that helped. And if you have any questions, post a comment.